Hello everyone. In this video, we will introduce the notion of random variables. We'll do some examples and we'll tell you what is discrete random variable. Well, remember that whenever there is a probability problem, we start with a sample space, yes? So the reordering somehow or packaging all possible outcomes, yes? But the entries, the elements of sample space, or what we call sample points, have nothing to do with points, with numbers. We want to somehow quantify these sample points or assign numbers to each of these sample points. Any such assignment is called a random variable. So definition: a random variable so you will see me for short, I'm writing RV, is a function. What is a function? Function is an assignment which assigns a number to each element of the sample space. So our sample space has, well, let's say x1, x2, could be different forms. What a random variable does is that just takes that first sample point and gives us a number, let's say 0. And x2 takes it and gives you another number 1. Another sample point gives you another number. So it basically quantifies these sample points. These random variables are very important when we are studying probabilities, and you will see slowly the theory will be developed and you will figure out why these are important. But for now, let's do some examples. A coin is tossed 3 times and we are going to define a random variable. Remember, when you toss a coin 3 times, well, the sample space is that, okay, either all 3 comes tail, then h tail tail, tail h tail, or tail tail h. Then there are possibilities like this, or all 3 coming out as a head. Yes. Now, the random variable x, this is the definition: the number of times that heads comes up. So the random variable x gives us, for this one, gives us 0. For this one, it has 1 head, so it's 1. For this one is 1. There are 2 heads, so that will give us 2 there. 2. This one also has 2, and this one has 3. So here you see that the possible values of x are 0, 1, 2, and 3. That's a random variable. Well, could have another random variable which counts the number of tails, or you could have a random variable which gives us just the number of tosses, or always 3. Yes. Well, is that a useful random variable giving constant values? Well, that's a different question, but that could be one random variable. A fair die is tossed twice, and then y is the number of times that x comes up. Okay, so if we list the sample points for this one, so can start 1 1 1 2 1 3, and this goes up to 2 1 5 and 1 6. Then 2 1 goes up to 2 5 and then 2 6. And this will repeat until we get 6 1, 6 2, and this is 6 5 and 6 6. I wish I could list all the numbers one by one, but here we'll just show you. So the random variable y, 1 has no 6 in it, so this is 0 0 0. Remember, this means the first rolling gives us 1, the second one 3. Here 0. This one, while the second one is 6, so it counts the number of 6s. This is again 0, this is 0, then there's 1 also there. Then this repeats until we get here. The first one is 6, so this is 1, this is 1, and this repeats up to this is 1. The last one, both of them are 6, so that's what gives us 2. So as you see, if you roll a die twice, the possible values of y are either no 6, 1 6, or 2 6. Good. This is another one. John draws a ball from a bag which contains 3 blacks and 2 whites. Well, in that case, okay, 1 by 1, that's important, until he gets to white ball. Okay, so here, either the first one takes, if it is white, just stops. That's one possibility. Takes first one is black, and then the second one is white. The first one is black, the second one is black, the third one is white. The first one is black, second one is black, third one is black. So all blacks are done. The fourth one will be white. So the random variable here, denoted by capital Z, counts the number of the balls drawn by John. While here, there is 1 ball drawn. Here, there are 2 balls drawn, 3 balls, or 4 balls. So possible values here for Z are 1, 2, 3, and 4. Okay. Let's do last example. W is random variable that measures how long it takes for London Transit buses in Route 10 to complete one trip from Natural Science stop to the White Oaks Mall stop. So this is a random variable. It's a little bit different in format because you see the result that at the time is not discrete. It's just continuous thing. Yes, while one day it can get at 10 minutes and 2 seconds, the other day it can go 10 minutes and 2 seconds and half, and it can be in any range. Okay, so first, well, you can say that, okay, minimum it will need maybe 2 minutes, or, well, more natural one is that you say that it takes at least 15 minutes. But just to ignore all these things, I will say that, okay, W is a random variable which can get any number, let's say any positive number, okay? Any number bigger than 0. Well, I'm doing very I'm being so nice here, saying that, okay, can go from any number to any number, only starting from 0. But in practice, basically, let's say we need at least 10 minutes, and it will get there at most in 1 hour. So that will be another 10 minutes to 16 minutes. Well, here the sample space is the trips. To each trip, you assign a number there. This number is a little bit different from the previous ones, and this number can be any number in the given interval. Okay, so Well, this then brings us to the definition that there are two kinds of random variables. One, which we will work a little bit more with, is called a discrete random variable. A discrete RV is a random variable for which the set of possible values is finite. So it only gets finite number of possible values, and that's it. Otherwise, it's called, it is a continuous random variable. So discrete versus continuous, we will study this in more details, but what is important for us here to see is that examples, the number of heads, which we denoted by x, the number of 6, this is y, the number of balls drawn from the bag, z, are discrete, but w, the time length, is a continuous. And let me finish the video by one convention. So we denote random variables with capital letters such as x, y, z, and w, and denote the values of a random variable by a corresponding lowercase. In other words, values of x we denote by lowercase x. Values of y we denote by lowercase y. Values of z, lowercase z, w. Okay? So this is the beginning of a very interesting theory that we will spend next 2 chapters of our course studying these objects.